Well, I hope the Google copyright bot doesn't flag me for that little noise. Right as I was getting the stream started, my hot water heater was telling me that it's got some water for me. And now Tuco's joining me up on the desk. Maybe we'll just get the camera over on him. Hi. Maybe that was a little too close. It helps if I remember what coordinate system this robot's in, especially since it doesn't have really automatic collision avoidance at the moment. Yeah, coordinate systems and cats. Alright, so welcome to the stream, everyone, anyone, whoever's joining me, either now or later in the archives. As usual, there are a lot of different things we could be working on. But I've had kind of a frustrating day, and I feel like unwinding at the moment by doing some more sort of reverse engineering / JavaScript hackery. And so in some previous streams, I had been porting this old game I like, Robot Odyssey, which is sort of a circuit simulation-based adventure game from the 80s. I've been porting it forward to work in the browser. And then we spent some time doing a full playthrough of that, and right now I'm actually just kind of entertaining the possibility of extending the game with external hardware. So like imagine you could, imagine, so in the game you have areas of the game that are sort of like rooms that you can walk into that you can wire up circuits inside of, and so you'll see these in the tutorials to some extent. But then the robots are sort of like mobile circuit rooms that you can go inside of. So they're like a place that you can hang out in, but it's also like a breadboard. And so it's this kind of cool combination. And they have these inputs and outputs just around the walls of the room. And then there's a similar room that represents a prototype chip that you can then burn into a smaller chip, which is kind of cool. I always thought that was like one of my favorite parts of the game, that you could design chips and then burn them into small chips. So that was cool. That was also implemented in the form of a room that you could walk inside of. And that kind of makes sense from the way the game's constructed. Like the game has sort of an almost like Atari 2600 style concept of, or like, Atari 2600 adventure concept of like rooms, and then an overall map that connects the rooms, kind of these low resolution playfield backgrounds for the rooms that also act as collision boundaries. And then these sprites that you can position in that larger world arbitrarily. And then the circuit simulation system, it's largely based on these sprites. They added some additional objects, wires and chips. And so the chips are sort of a more efficient format for dealing with larger circuits, and they get compiled into more like a netlist, which then runs kind of once per tick. Hey, Microhex. Yeah, so circuits chips are kind of like sort of bytecode netlists that are operations to run once per simulation tick. And right now, there's a lot of unused space in that bytecode language. It's basically byte-wide operations, but there are only really a few of them right now. I think there are only like 7 of those 256 opcodes in use. So there's a lot of room to add additional stuff to the chip language if we wanted to extend it that way. I think it would be really interesting to have rooms in the game that corresponded to physical objects, like a room that you could go into, which was then your Arduino. And maybe the same way as the game has a concept of prototype chips and small chips, maybe you could do something where you could have like a prototype Arduino that's sort of connected via a USB umbilical, and you could wire a circuit in there. But then you could also like burn that down to assuming you didn't use like features that were, maybe there are additional features that are in the prototype chip but not in the final chip, but I'm imagining that it would probably be one-to-one, sort of like the prototype chips in the game. And so that could be kind of interesting. I mean, it's not the most practical language to write microcontroller circuits in. You know, this isn't intended to be like a practical, like how you would code your project in 2018. It's more like, oh, this is a kind of fun game, and other people who are also kind of a fan of this game might enjoy interacting with the physical world with it. Plus, it might kind of spread ideas about how game worlds and physical worlds can interact, but I mean, honestly, I think a lot of people are doing that nowadays. Like, I think given how much I/O there is between like Minecraft and the physical world, like I'm not going to be doing anything new here. It's mostly just I think it would be interesting to do something like that with a game that I find personally satisfying. So anyway, I don't think we're going to be doing that quite yet. I think that might eventually involve, I was looking into connecting it with the microbit over Bluetooth, and horrifyingly enough, there's actually a web Bluetooth API, which at least on Chrome, you can use to attach like Bluetooth LE devices to JavaScript apps. So I don't know if that's a good idea, but it's a thing we could do. There's also web USB, which is less extreme, I guess, than like web Bluetooth maybe. And I'm sure there's maybe like fewer devices that we could interact with directly over web USB, but I'm sure there's a few. So yeah, something like an Adafruit board or a MicroPython board or a microbit, something like that would be really nice to interact with. Anyway, I think there's some prerequisites. So first of all, I don't quite understand enough about how the circuit simulation works to actually implement that bridge. So I think there might be some reverse engineering to do today. I roughly know that there are these three areas of memory that are relevant for what we're doing. There's the sprites, the wires, and the chips. Well, wires / gates, I guess. Maybe those could be the same or they're separate areas. So the game's built on this kind of generic sprite system, as I was saying. And the sprites are these, I think they're 7 by 16 pixels, the native resolution. But it's pretty easy to link together multiple sprites so that you can make larger objects by having multiple linked smaller sprites. And so pretty much everything that you move around, like I guess there are some game obstacles that are made with playfield blocks, like some doors, but pretty much everything that isn't made of those chunky, super big pixels, those are sprites, or text. I think there's also like a separate kind of graphics object, but there's a generic sprite object for things that you can move around and pick up, and that can be picked up by robots, that can pick up other objects, like all of those are the same kind of thing. And so there's a set of tables in the original kind of game engine that Robot Odyssey was built on top of. Since Robot Odyssey itself is built on top of this simpler game engine that I first saw in this other game by the Learning Company called Gertrude's Secrets, which is also kind of an electronics game. But I think the engine itself even predates those two games. Like, I think the engine was written by Warren Rabinet, and you can see credits for him. He's the author of Atari 2600 Adventure. So I think at some point, I don't know exactly the history that went on here, I think at some point Warren Rabinet either just came up with the concept of this engine or was actually part of the effort to port it to DOS and Apple II from Atari. And then that probably was the original sort of level editing tool / game engine for Gertrude's Secrets and Rocky's Boots. Rocky's Boots used a very early version of it. Gertrude's Secrets used a version much closer to what Robot Odyssey uses. Same as, what was that other game from Learning Company that I didn't play? I keep forgetting the name of this one. They did a game after Robot Odyssey that I didn't play. That does also use the same engine. And those games all use the same format for this part of memory that I've been calling the world, because it comes in a .wor, like world file. And it's like 13 kilobytes. It's the same in all these engines, in all these games. And it's really sprite positions, links between sprites, world, like kind of rooms and playfields and links between rooms, that kind of stuff. So there's that layer. Robot Odyssey has that, and then they imbued it with this additional layer of meaning, where the color of a sprite is actually also used to indicate electrical activity. So the game operates on, I forget how many colors are in the palette. It's like roughly a 16-color palette. I think it's a little bit less than that. the game runs in CGA mode, so it's actually got 4 colors in the CGA palette, but then the game uses some dithering patterns to produce more than that, and so the game conceptually has like something like 12 colors or 15 colors, I think. And I think, there's basically a 4-bit color table, but there are some duplicate and not especially useful entries in there, so it has fewer than 16 actual colors. Anyway, 2 of the colors in there are actually reserved for, they appear as like white and orange on the screen, but they're actually like logic 0 and logic 1 as colors. So a lot of sprites, including the player when you're using the hot cursor, logic gates, input and outputs in your robots, like nodes, a lot of those sprite objects, actually the color encodes the electrical state. And then there's some additional memory that they added in Robot Odyssey beyond what was in the original game engine. And I've been calling that the circuit in my reverse engineering so far, but I don't know if that's really an appropriate name for it, because like a lot of what you might consider to be circuit data is really implicit in the sprite table. And then the chips appear to be in a separate area of memory that's outside of what I've been calling the circuit. So and then the circuit also includes like game state, like is the toolbox open, like flags for the various puzzles. So it seems like it's more just all the stuff that was game specific and not part of the original engine. Let's see if I can get a slightly different view so you're not just like looking at the side of my face. I don't know. Oh, got a little shimmy. Oh, I really need to do some more tuning on this algorithm. I know you're probably tired of me saying that. That's a different angle. I don't think it's actually better. That's better. We'll get to these two. I know I've been putting off these packages, but I'm sorry, gotta do something software related today. I don't think I have it in me to do the software, or to do the hardware. Oh, yeah. The Yeti was saying that they hope my hand is better. Yeah, no, it's fine, thanks. It was bleeding for a little while, but, yeah, so I had kind of an annoying day. Part of the reason I wanted to work on something fun today was I was in the city for like some errands, like mostly going to just a routine doctor's appointment, and on the way back I broke my phone. I like just dropped it on the sidewalk, and I obviously need a better screen, better case. My phone case right now has a scanlime on it. It's like an off-the-shelf case, that's the original logo. But then I engraved a scanlime into it, and I like it, but it's actually missing some protection along the bottom edge. So dropped on the sidewalk, shattered. So then I spent a bunch of time today getting my phone fixed, and while I was at it, getting the Apple Store to replace the battery. Because the battery had been in need of replacement for a long time, and just last time I cracked my screen, I tried to get them to replace it, and it wasn't quite bad enough for them to replace it. Anyway. And then it turns out that the phone left a bunch of broken glass in my pocket. So, yeah. I had a feeling it would do that, so I was trying to avoid the broken glass, but then I got careless with it after I got my phone fixed, and I got some under my fingernail, and that was not so fun. So I was like bleeding on the subway station because of the broken glass in my pocket. Anyway, that was my day. Now I'm gonna drink some tea, drink some beer, and hack some robots. So yeah, it's got these different memory areas. It's got the thing I've been calling the world, which is sort of the legacy area that it inherited from the original game engine, whatever that was called. And then it's got this circuit data. That's been largely a mystery so far. I've not done much reverse engineering on that circuit data so far. I know it has some arrays for wire locations, which I think are just stored as XY locations of each endpoint of the wire. And then some information about connectivity, like which sprite the wires connect to. It's easy to get that information out of sync if you move the sprites manually. Manually, I mean by editing these tables. I want to write some utilities for editing these data tables. I did this a while ago a little bit in C++ and just wrote some tools, for example, to move sprites around, move them to different rooms without causing inconsistencies in the linked lists. And so we might want to port that stuff to JavaScript and add on to it. So the circuit definitely has wire tables, which also have some links back and back at least to the sprites. It has states for all the gates. So I've already noticed it has like an array of all the flip-flops. It has an array of all the other gates with information about the states. I've noticed it has multiple state arrays. So it might have like a previous and a next state or something like that. That's something else to look into. That also has some unrelated game state, like puzzle state, remote control, and toolbox state, and stuff like that. And then there's the circuits. Let's see. And it's been a while since I looked at the circuits, but actually I looked at that stuff in detail back in like 2009 and wrote a blog post about the circuits. There's some other kind of out-of-line data for like pin states and pin directions, but the circuit itself is basically just a 1 kilobyte blob of basically bytecodes that can do some operation on a list of inputs and write the result to a list of outputs, basically. And the circuit's implemented like that. It's sort of a primitive netlist. Welcome to the being nice to cats part of the stream. Oh man, Tuco was just being super cuddly earlier today. Because I had my misadventure, and then I got home from that and found him upstairs, and he was just sitting on something tall, looking out the window, and I came over and started petting him, giving him good head rubs, and we just had a good dialogue, him showing me how he wanted to be pet, me petting him purring, looking out the window and purring some more, licking me, changing positions, doing some more petting. It was good. I like interacting with cats like that. Maybe get another good view here. The robot just wants to look at the cat. Maybe I can compromise here. I think the robot's got good taste here. So yeah, there are a few things to look into. One thing might be just doing additional reverse engineering, so understanding how this stuff works. That could lead to, plus I already have some existing information that could be useful for just like having more JavaScript tools for interacting with the game's memory. And I think the answer there is to write most of that in JavaScript. I'd like to avoid having a really thick interface between the JavaScript and C++ components, and it does seem like I want the easy to hack on parts to be in JavaScript if possible. So my inclination is to write just pure JavaScript libraries for accessing the game data. Basically replace the C++ code with that, maybe even delete some of the C++ code once I've got it moved to JavaScript, because it mostly doesn't need to know the game state. There are a couple of areas like for loading games. Whoa, sorry about that. Oscillation Town, population us. So yeah, just JavaScript utilities based on new and existing reverse engineering could be nice. The other thing that seems obviously useful is to have callbacks so that we can write JavaScript code that gets an opportunity to run, for example, on every circuit simulation tick. That would be nice. Because like right now, you can just write a JavaScript set timeout, and you're already guaranteed that your code runs only in between game frames. It won't get called like in the middle of a frame, because I've already, like, the game is not interruptible. It runs, until it hits a continuation function that I've inserted, so it's basically cooperatively multitasked with your browser, and so it doesn't give up control flow unless the game's in basically a consistent state. So, and in fact, you can, if you want an even stronger guarantee, you can check to see if it's possible to save the game. And that internally in the engine actually checks to see if the continuation state is at a very specific spot. So yeah, so it's already possible to interact and to not really corrupt data structures like linked lists that need to be updated consistently, but it's not really possible to consistently, do some input or output on every single game clock tick, and that would be nice. So it'd be good to maybe add a callback where you can add a JavaScript function call per simulation tick. That could get called only if the remote control is active, or it could check the remote control state maybe. Anyway, I think the first step here might be just to first document the actual remote control on-off flag, and then we can go looking for where that's accessed in the binary to try to find a good place to add a hook for circuit simulation. So I was just doing a build that we would have a fresh build. Oh, for doing JavaScript work, it might actually be worth setting up a Webpack dev server. I've been just remaking it because so much of this stuff is like stuff that Webpack doesn't know about. Alright, so here's the game. It's got a little bit more UI down here. Here's the sandbox portion of the game. You can make it run faster, which is nice. Let's make it run 2x, which is a little bit less laggy than the original speed, but isn't crazy fast. So, oh, hey Took, you're all right on my keyboard. I've got some notes here. Yeah, so I had this utility I was using before to do memory diffing. Let's bring that up again. It's just a little function that just walks over two arrays that I'm assuming are the same length and just logs any bytes that are different in between them. So let's get that. Let's also make a little shortcut that I've been using. I usually make this variable called W that's my world array. Although I might actually want to be looking at the world and the circuit in this case. Let's use G for game. So RO engine is this global object that's exported by the JavaScript code on this page. We can ask it for this game memory thing, which is a little JavaScript object that includes several different memory regions that are relevant to the game. And I've just been packaging up any discontiguous regions like this. So each one of these is a data structure. I've just been noticing the different regions as I figure out how this game stores things. This first block, that's 13,568 bytes, that matches the .wor on disk world file format. So if you find one of those world files, for example, in any game that uses this engine, you can paste it onto that array, and this engine will sort of kind of run that game world, which is neat. And then circuit is the stuff that's unique to this game. For the most part, there's some other areas. There's this robots array. There's also going to be an array of chips. It just isn't here yet, but we should reverse engineer where the chips are all stored and add that to this. One other complication is that these are all going to be slightly different depending on which game binary we're in. So right now we're in lab.exe, which is the innovation lab. The two others that are relevant here are game.exe, which is this one. And in fact, if I call get game memory here, this is actually going to give me different arrays. And in fact, even the length is different. The main game has 4 robots, whereas the lab only has 3 robots. I think they might have used some of the memory that they saved for the 4th robot to implement the giant chip. And the tutorials are yet another binary, except for the last tutorial, which is actually implemented by the lab binary. So then if I run this in the tutorials, I get yet another array with 3 robots this time. So Yeah, so we need to figure out which one of these we want to concentrate on. Since they're going to be different in subtle ways, it'll probably be pretty much the same underlying code, but the memory addresses or instructions might be a little different. For the most part, I've been solving that by using pattern matching to look at the binary or the memory space to find the data structures I'm interested in, and then to have per exe file code that gets generated to give me those individual entry points or addresses. So let's look at the innovation lab. Let's make sure we have the current game memory array. So we have game memory, we also have that diff utility. So let's see. Let's say we just want to look at the remote control state. I think right now there isn't really anything wired up, so I wouldn't expect much to happen if I turn the remote on or off. Let's just toggle it a couple times just to make sure that anything that would have happened the first time is done with. And now let's take a memory snapshot with the remote control off. Let's call this ref for reference. Let's do both the world and the circuit. Maybe let's make a function that copies, that does like a deep copy of this game memory. Yeah, let's just make functions to do both of these so that it's a little quicker. Let's just make like game copy and game diff maybe. So let's see this. I'm just going to use the globals. Is there a built-in deep copy? I don't think any of that's what I want. The way I've been doing this is using slice. I'm not going to worry about the robots array right now. Okay, let's save that function. So usually I actually want the fact that when I, so like these are actually subarrays rather than slices in JavaScript typed array terminology, I guess. So instead of being a copy of this memory, it's actually referencing the same memory that the original heap for the WebAssembly was taken from. So when the game modifies this memory from what it thinks is 16-bit assembly language, it's actually modifying these arrays in JavaScript. But in this case, we actually want a deep copy so that we can save this state and then compare it to a different state later. So then let's make a function like gameDiff maybe. And let's just do two different diffs, one section for the world and one section for the circuit. Oh, Tuco. Yeah, this is not going to be the prettiest, but we're feeling our way around here. I'll save that in my notes too. Alright, let's see if that works. So let's say ref for reference equals game copy. Cool, so no differences there. But let's say we turn on the remote. nothing else. Well, we did an autosave there because there was some user input. So, that's interesting. That's not quite what I was expecting, actually. I was expecting that there would be a change in the circuit because that's where it seems like sort of game state flags go, and I figured this would be just a game state flag, but instead we got these changes in the world. So these might be in multi-purpose areas of memory. So just like the colors of the sprites encode electrical state, maybe the visibility of the remote control sprite encodes whether or not the circuits are on. Let's look up what these values actually mean, according to the most recent notes. So I've been keeping notes here in this C++ header file, which might eventually get turned into JavaScript. So we got a difference at 1FC, which was in the sprite ID table. So I assume FC is the remote control sprite. You know, I bet I already reverse engineered this part. Maybe I didn't. This definitely sounds like something I could have reverse engineered a decade ago and then forgotten, right? Because I did have some info in the old port. Let's check that briefly. I had this UI. You know, maybe I didn't actually know programmatically the remote control state, because I remember the old Nintendo DS port would draw the remote control properly, but I don't think that was because I knew it programmatically. I think that's because... Oh, no, it was both. I was going to say it's because it was using a copy of the game's actual renderer to draw the game, or to draw the sprite, which it was. But I think it uses the game's data to know whether the toggle button for remote control should be toggled or not. So how does that part work? That might have even been the right file. UI subscreen. This is even the class for the remote control button. So activating the remote control on this UI would just press the key R. Oh man, this is it. Yes, update state. Sprite ID RO object antenna equals sprite remote control. So yeah, I did figure this out a decade ago. This is in the header file, not the CPP file. So yeah, antenna is OXFC, which changed from 1A to 3.6. Oh, did I not label these? Ugh, why? Why did I not label these with hex codes? Oh, that's annoying. Maybe I should do that. I was like, these are all in order, basically. Oh, that's cool. Jarrett chimes in that there's a plugin for this in Sublime called Insert Nums. I was about to write a little throwaway Python script, but if there's already a plugin, that's pretty cool. Oh, is this like a... I thought this would be like a C++ enum thing. Is it just like for just inserting lists of numbers? Can it do hex? Looks like it can. Alright, let's give this a shot. Appreciate the hint, thank you. Nope. No. How do you even keyboard? I feel like I just can't do modifier keys anymore. Oh, that was it, actually. It just did something. It inserted a single number. Okay, that's not what I wanted. Oh, okay, I missed the prompt here. It was waiting for me to insert a format string. Okay, let's look up what it actually wants here. What were they doing with this format language? Are they gonna make me read this entire novel just to figure out how to insert some numbers when I could have written 3 lines of Python? See, like, I thought the point would be to use an expression language people already know. Like regexes or format strings or something. I hate this part. Ugh. It's like, could you have made it any more obscure? Really? Okay, I hate this so much. I'm uninstalling it. Sorry. Yeah, no, sorry, that's absolutely not the user experience I'd want. I appreciate the suggestion, but wow, I'm just gonna write a Python script. Oh gosh. I'm gonna have to adjust this. Well, that includes a new line, doesn't it? Oh, hey, Tuco. What did I miss there? Can I not actually do that? I thought I could do that in Python. Oh gosh. I still have that in my paste buffer. Watch me fail to use a computer. Well, I think I lucked out with this width, although I wanted a little bit wider, actually. I really thought you could put those on the same line. Maybe you can't anymore. Okay, so I want that to skip the blank lines, and I'll fix that one up manually. Do I need another set of parentheses for that to be a generator expression? This is like a part of Python I don't use much. I thought I could have a generator expression with a conditional section. Maybe that goes before the for. I'm going to look up how that works, actually. So I should remember that. Not the part that I'm looking for. Really? I thought that's what I was doing. Oh, I just missed some for parts, I guess. Wait, you can do if, but you can't, or you can do if with else, but not without else? Really? What is the point of that? Okay, here's an if at the end. Is that just a different kind of syntax, having the if at the end? Yeah, okay. What was I doing wrong up here? Oh. That's better. That's the sprite table I wanted. Yeah, and much rather brush up on my Python than learn some weird plugin syntax today. Oh, is there really... How did I end up with 3 spaces? Ah, that's fine. So it went down to unused 2. Why did I put a little division between crystal and grabber? Okay, because I guess that's where this starts. I guess that really should keep the equal 0, shouldn't it? Alright, fine. So 1A, what was that actually before? Blank. 3.6, which I assume is radio. Yeah, remote control. And then 2F6, 2F7, where were those? So that was changing the color of sprites, F6 and F7. Were those maybe bumper states? Oh, the crystals. Okay, that's unrelated to what we're doing. Those are just the crystals alternating color. Okay. Cool. Well, that didn't really accomplish anything, but I now have some stuff loaded back into my brain that apparently had migrated elsewhere. So I think the thing I actually want to do now is just look at the game disassembly and try to find a pattern for matching the function that gets... Like, I don't know what structure this will take, whether it'll be maybe a function that gets called only if the remote control state is set, or like where that check will be made, but let's look for a landmark that's close to that area, either right inside it or right outside it, and try to find a way to add a hook function right there. So, yeah, I mean, we could, there's some other stuff we could do before we, like, go deep into the code. Like, for example, let's make something where there's a circuit, like, right outside this chip, for example. Let's put a NOT gate right here. And maybe another one, oops, stay outside the chip here. Maybe another one of the other polarity on the other side. Alright, letting the electricity flow there. Let's see what the diff looks like now. So same reference as earlier, but a current game memory dump. A lot of stuff now. So there's a bunch of stuff in the sprite area. Some of these are positions. You could start to get a catalog of which sprite indices are being updated, or which objects rather. There are a lot of objects here that are not cataloged. I don't think I've cataloged any of the gates, for example. Yeah, there's just like a bunch in here that needs work still. Anyway, I wanted to demonstrate the inputs and outputs on these chips really quick. I've played around with this a little bit, so I know a little bit of what to expect. This is not outside of what we've explored in the reverse engineering so far. Let's take another reference. So no diff right now. Oh, thank you. Okay, so if I were to go over here and just flip the state of this one, so I have some circuit changes. I think the circuit's also using parallel arrays at this point. In fact, I might already know what these are. These might be wires. You know, I think the array that I have listed here as wires is actually more like electrical entities. Because I think the hot cursor actually counts as a wire. I think what this is showing is moving the location of the hot cursor. And the other state changes here, I think, are attributed to sprites. It's like, what's at E? These are object list head pointers. I think that's from just moving from room to room. 5, that's the location of the cursor and the remote control and the player. What is the difference between FE and FC? Yeah, so I'm also not entirely clear about these distinctions. There's a player, and then there's a cursor and an antenna as separate objects. So the antenna makes sense. It kind of hovers above the player and it has a different sprite. I don't know what the difference is between the cursor and the player would be. This might actually just be the hot cursor, because I don't think I see that in normal gameplay, but we could double check that. Alright, so then is 2 the color table? Yeah, 200 is the color table. So all of these colors changed. So we had a change in the player. What is 201? Yes, I don't know what that is. You know, it would certainly help to just have a general purpose like debug tool for the sprite table. That's a pretty obvious kind of level editor sort of thing to do. I'd been just kind of putting that off because it seemed more interesting to go just directly to the circuit, but the circuit is so intertwined with the rest of the sprite mechanics in this game that maybe that makes sense. Anyway, then 204. So like these objects, for example, they all have X, Y in a room. We could add little overlays that actually show like object IDs for each thing on the screen. That would be pretty fun. You know, actually in the lab, I think those early sprite numbers, like right after the player, might actually be pins. So actually, I think this pin, 201, might be this, and I think that's 204. Let's test that theory. Let's maybe just periodically display these. Let's just do this, have a function that diffs the current game and the reference every, I don't know, half a second. Oh, let's make it a little more obvious when one of these ends. Does that work? Yes, kind of. And let's even just make it 1 second. Okay, and let's take another reference since a lot has diverged, it looks like. Okay. Okay, now I can toggle this pin. So we have color changes on 201, 204. Then there's also 239, 23C, 26A, 26B, 2F6, 2F7. So my theory right now is that those early numbers are the prototype chip, and that those later changes are actually the gates outside. In fact, we could just do, with this handy little diff thing, I mean, I was reaching for the prototype chip first because that would be convenient for, interfacing, but I need to connect something to the prototype chip or the pins have no direction. There's a bunch of changes. Let's zero out those changes again. So that pin was 202. These are definitely going to be specific to the Innovation Lab, though. So, like, I've already got some stuff here that's only in the game, so, like, what do I call this? Prototype chip, maybe? Protochip. Big chip. I think that we're also going to see different pin numbers for the inside and the outside of the chip. So this is 202, 23A. One test I could try is energizing the same pin but using a different gate. so tempting to just add an overlay for sprite info though. I think that would help me debug these way faster. Maybe we should take a detour and implement that. Oh, my friend made some rice and mushrooms and it looks like they had some extra, so I gratefully accepted a gift of rice and mushrooms. Yeah, how should we do this? Should we maybe just have DOM objects on top of the canvas that try to line up with these sprites and have extra info about them, maybe? I mean, I feel like we can map out some of this pretty quickly without going on such a major detour, but it's a compelling idea, right? Like, it would be really fun to have that. And it would make this part really easy. Anyway, let's just leave the gates alone for a sec and just attach input nodes to all of these. And I just want to light up all the pins from the outside and get the addresses of those noted down. And then we can look at the actual gates, maybe. Yeah, I don't know. I think we should do an overlay. I think that would be much nicer. We could even draw it into the canvas. The issue with that is that it would be really low resolution because the canvas is only 320 by 200 right now. I mean, we could make the canvas higher resolution. We'd probably want to make the canvas an integer multiple of the actual frame buffer, though, which still gives it a weird aspect ratio. We could just make separate DOM objects, maybe. This is a major detour, isn't it? Because, like, I could have something that goes through and every frame scans the game's memory and makes some updates to have the DOM kind of conform to whatever that looks like. Now I need something that, like, diffs DOM subtrees and, like, well, whatever. I'm sure I could import some huge pile of JavaScript that would do a lot of this for me, but it makes things more complicated. I mean, actually, no, it doesn't have to be that complicated. What if I don't make anything complicated? What if we're just still in the domain of, like, throwaway scripts I can paste into the console and, excuse me, and I just have something that scans the sprite memory and looks for sprites that are in the same room as the player and then annotates them on the screen by just creating divs that are absolute positioned, I guess. I feel like I maybe should just put this on the frame buffer, though, because, like, otherwise I'm going to have to try to match up the divs to the location in the frame buffer, which is not the most trivial thing to do right now. Like, it involves figuring out where the canvas is and then doing that scaling. How hard is it to just stuff things on the frame buffer from, like, throwaway JavaScript code right now? Because I don't think I have a canvas context, but we can get one. Okay, let's turn off this watch interval. That's how this works, right? Get canvas, or get context 2D. anyway, so no reason to expect that I would notice that in between game frames. What if I slowed the game down a lot? Fill text. I was expecting that to come up kind of in the top left, but that might be referring to like the bottom of the text. Let's try. Oh yeah, I think it's just black on black right now. Fill style. Let's just make this white or something. That color didn't work because I spelled it wrong. Yeah, that works, kind of. So then what if I wanted a hook that let me draw something like that on every frame? Because the engine already has a rendering callback I can get to from here on render frame. So let's save the original maybe. Yeah, the original on render frame is actually pretty simple too. Okay, so if I wanted a new renderer, and I could add some extra code to that. Let's actually just call this, oh gosh, to go. Let's just call a function, like a global function called render on this context so that I can add stuff to it easily. So I'm going to call that, and then immediately I start getting errors, but then I'll fix that. Let's save that too. So this kind of installs a hook. And then did I do that right? Oh, I don't think it kept trying to render after it hit the error. I think I broke the game's main loop. I don't have a good way to fix that right now. Does this work? Oh, it does. Cool. I still had it slowed down. Alright, so we've got a pretty ugly but sort of present text overlay there. Let's see if we can make that a little nicer. Are there any pixel fonts I can get? Actually, how do I figure out what fonts like Chrome has access to from here, just for testing? Would it just be anything? It would be anything installed. I don't think I have anything especially interesting installed on my system right now. Is this any more readable? No. Okay, well I can kind of make that out. That'll be enough for labeling sprites. So this could be a starting point. I think we want to go through the sprite table now. Okay, let's use this world shortcut from before. And let's break out this render function. So I want to loop over all the objects. Let's just assume there are 256 of them. Let's just call this ID 256. We should also look at the current room up here. That is at OX 300. 300 is the current room table, right? So we care about 300, and then 400 and 500, and then we'll print out the ID. And we'll just print the ID on top of the object, just to keep this simple. So X is at 400. There is a linked list in the game that lets you quickly find all the objects in the current room, but I'm going to do it the brute force way. Because who knows, maybe this will be illuminating. Okay, then the coordinate system the game uses is a little bit weird. It's half resolution horizontally, and it's inverted vertically using a slightly weird height because the game's actually 192 lines high. Let's see if that works. Oh, I messed up X and Y somewhere. It's close though. Yeah! So now we can actually see that some of these objects are made of several sprites. So, ooh yeah. So here's all the internal parts of the robot. We could even have it draw the text in the same color if we wanted. Just find the right color table. So we've got the antenna, there is FC. The body of the cursor has both 0 and FE on it. Seems the same whether you're in hot cursor mode or not. Robots have a few pieces here. What is this? I don't know what 8E is or why it's in my room. Yeah, no idea what that would be. Let's pick a color that I can actually see on top of more things. Maybe a slightly bigger font. This resolution's kind of terrible, right? Oh yeah. This is a little hard to read, but you can see what's going on kind of with this big chip. So the pins on the left are 1, 2, 3, 4. Oops. The pins on the right are 5, 6, 7, 8. And then the chip itself is made out of 9 A, B, C. Oh, good question. Is 8E where my toolbox was? Toolbox is E1. This also makes it clear which objects aren't sprites. Like the crystal recharger is not a sprite, the text is not a sprite, the shape editors are not sprites. I'm also leaving little like 1 pixel bits of junk around the edge of the screen. Actually, I should clear that in my renderer wrapper. So we could also map out the whole contents of the toolbox here. Right? Like, this is starting to explain why there are so few parts in the toolbox. Like, everything fits in the same 8-bit address space here. Looks like the node started at D1. So I assume the electrical parts, like the gates and the nodes, are going to be the same. Probably the chips will be the same, but then the robots and the big chip will have some differences, and then there might be some world-specific objects. It's like tempting to split this up into different tables for each game binary, but I don't know if that's really productive. This is also a bit disconcerting because clearly the game at least sometimes numbers the pins like this, but you certainly see them numbered in the standard electrical convention of counterclockwise in the documentation. So I should probably just note here that I'm using the electrical convention. Because I don't know what else to do. Also, the outside and the inside pins are different, right? Yeah. Big chip outside, maybe? Do I like big chip or proto chip? Proto chip. Oh gosh, I really hate the tab completion there. I need to turn that off. When you tab complete and then it turns it into a completely different number. Okay, let's label that according to the convention I would prefer to use here. That's 1, 2, 3, 4, 8, 7, 6, 5. And these would all be similar. So it's interesting why they actually have totally separate sprites for inside and outside. Like, I think it's largely just the limitations in the sprite system and how, like, if they did want to share numbers, even though they have the same electrical state, they have different appearances, like one's input, one's output, they're in different rooms, and they probably would have had to do so much special casing in the rendering system that just wouldn't have been great. So I don't know, man. It seems like this is an alright approach, but it'll definitely mean that we want to take a close look in the code at how the signals propagate between the inside and the outside of the chip if we want to start injecting signals into this part of the system. So, inside pin 1 starts with 3, 9, and 3A, 3B, 3C, and then D8, oh, that's so hard to read, D8 through D5. Those are not at all contiguous, right? Oh, sorry, those are my nodes. Okay, those are contiguous. 40 through 3D. Three F, 3E, 3D. Alright, toolbox items next, maybe? Oh yeah, they totally used the same sprite resources for the master computer that they used in the big chip, which kind of explains some of the visual artifacts you get if you were to load the save game files in the wrong binary. Let's maybe have maybe a section for game only, innovation only, and common, but otherwise use the same enum here. All, I don't know if I should say all there, but we'll see. Innovation Lab. This is, we'll probably have a better naming convention for this. This is stuff that's inside the, inside one of the regular robots. These are the grabber inputs. I must have seen this in the code somewhere and felt like annotating it. Innovation Lab. MC. Chips. Okay, we might reorganize these sections if it becomes clear that they have a gap at a specific point, but actually, yeah, it does look like the game-specific thing should be first, and like most of the common stuff is at the end there. Are you okay, Piot? Innovation Lab. Common. There's a robots, the toolbox. Okay, let's see about gates then. Let's get a fresh Innovation Lab. Okay. Let's speed this up a bit. Yeah, I like the rendering hook approach to just add stuff on the frame buffer. I'd certainly get more resolution drawing it in the DOM, but then I'd have to worry about converting the coordinates more so than I currently am, which wouldn't be that bad. Maybe we'll do that soon. It'd be a nice enhancement. So D1 through DF are the 15 nodes. Hey, Tuco. I don't know if there's a better approach than just duplicating these lines. I mean, it's not like C has parameterized macros, or like parameterized enums or whatever. Tuco. Tuco's doing his usual set of things, trying to tear apart all my stuff. Oh, we had some good playtime earlier today. When I came home, like, stressed from my errands and having broken glass in my pockets, Tuco was relaxing and we just hung out together. It was cool. But now he's back to being demanding. Close enough. I'm running low on patience with the cat yelling at me. Let's make those one based maybe. I don't know. Like, I think in code, I would probably refer to these as like node 1 plus a constant, for example, but this at least makes the table more clear, maybe. Flip-flops, what? Okay, flip-flops are 2 halves here. 2, 5, 2, 6, 2, 7, 2, 8. The game only has 10 flip-flops. This might explain why, also the circuit array also seemed to just store the state separately for the left and right halves of the flip-flop, which seemed weird and redundant. I wasn't sure why it was doing that. So oh, Tuco. 2, 5. Something like that. Flip-flop 10 right, flip-flop 10 left, etc. go. This should also be way up in the table. If I'm gonna keep it anything like sorted. This might give some clues as to when they implemented stuff too. Like, I got the feeling the flip-flops might have been the first thing they put in. Alright, so what about these gates? Are they gonna be different per type? Oh gosh, what a mess. Can I have the font be different, please? I probably could actually change this rendering function to boost the resolution of the canvas without doing too much additional fussing with this. Because it's just really hard to read this right now. To go. Let's add that 9ABC. So like, I'm expecting the gates all use the same memory because they come from the same pool. So like if I put these gates back, yeah, it's reusing the same sprites for a different kind of gate. So this is like 6, 7, 6, 8, it looks like. I mean, I'm expecting this to be at least a sprite for the output and a sprite for the body plus output and a sprite for the input. Maybe the body and output are separate, but it looks like that's the same. An individual sprite can only be a single color, so part of the reason they're breaking these up is so they can have the input and the output be a separate color here. But the flip-flops are not broken up like that, so the input side and the output side of a flip-flop can't be a different color the way they're rendered. So for example, if I just cross-wired this flip-flop like that, then this wire is logic 0, but the input it's connected to actually has to be the same color as the left side of the flip-flop, so that draws as red. So that is not a single sprite though. It looks like there's two characters struck over the 7 there. Okay, let's just get an AND gate. So 6, 7, 8, 9. A, B, C. Okay, so maybe it is just 3 sprites. Is this maybe just like the unused input is just being positioned over where the body of the gate would be? So I think maybe the gates are all just going to be 3 sprites per. Let's see if that checks out. So 35 gates. And then it would be body input 1, input 2. Let's see if that checks out. Is it always the left input, I wonder? No, 7, 8. I think that would be 9. I'm just gonna say input 1 and input 2. So we should see those going all the way up to CF. There is a little bit of room in between the gates and the nodes. Oops. I'm always using the wrong modifier for the multi-select in Sublime Text. Really? I thought I was Control and Alt, and I keep messing that up. Yeah, of course. Control Shift. Oh yeah, okay, I guess I expect it to involve Alt, and it doesn't. And that's what messes me up. Okay, so does that actually take me to CF? Last gate. CD, C. Oh, it's so hard to read all of this. It looked like the body was at least CD, so the input should line up. Okay, I don't know what D0 would be. It seems like that one's kind of missing, right? Okay, what about the insides of robots? Which robot is robot 0? It seems like scanner, checkers, and then Sparky. Oh, here's the little chips. Do I have all of them? E7 through EE. EF. Wait, really? I think I have that wrong. This is definitely E7 through EE. Okay, so you can see the parts of the robot here, F0, F1, F2, F3, F4, F5. That corresponds to these. Oh yeah, we can just knock out the stuff in the shape room too. So it looks like there's a bank starting from D, E, F, 10, 11, 12, 13, 14, 15. That's just like a bunch of sensors. And then separate pins for the inputs and outputs. And I don't know if these are common to the game. I figure they probably would be. But we can revise that if necessary. Keep these in order. Sensor. So there are 9 sensors. Those are some weird gaps in the numbering too. Like it almost implies that maybe these sensors have a 2 output variant or something. I don't know. Maybe it's just the way it is. Is that really 11? Can't quite tell what that says. I think that's 11. We can make the text a little bigger maybe. Best color picker. Oh, that's terrible. Okay, fine. Yeah, maybe I should label these directional sensors. DIR1 maybe. And then these could have outs labeled 1, 2, 3, and 4 maybe. 5A, B, C, D. Yeah, I kind of want to keep these in the order of the sprite table, so that leaves these probably elsewhere. ABC, then EF, yeah, etc. Yeah, a couple of gaps still. Crystals, F6, F7. So these are like, maybe I'll call these shapes, because this is, like, I think these in the game are just objects you can change the shape of, so the game uses some of them as crystals and some of them as other things. And are those 6? Yeah. So 19, 1A, 1B are the room sensor outputs. Alright, and then that's 1F 2021. Okay, this is looking good. Let's document some more of the robot parts, and then maybe we want to go into the binary and try to figure out how to add a circuit hook. Oh, fast mode. Robot. Okay, scanner is first. I think we might have already have these. So this is E, or okay, sorry. 41 through 48. Let's take into account. Then we also have some stuff up here. E4, 1E, E2, E3. E4. This is scanner, grabber, out. And then we also have antenna, input and output. Antenna in is E2, antenna out is E3. Yeah, starting to get some continuity there. Yeah, this table is going to be a mess, though. I think they just put stuff wherever they had room. Next robot is checkers. So I think I have the thruster parts here documented already. Yeah, that's 4.9, 350. Looking good. And we have 1D, EF, E5, E6. Huh. EF is way down there. This is checkers. Grabber out. I'm like wondering if I should be calling them by their proper name, or like Robot 1, Robot 2, or Robot 3. Okay, next robot. Yeah, and then this one's a little different. I should really check out the master computer and put that in this table too. Sparky, 51 through 57 on the thrusters and bumpers. 1C, which we had for that. Grabber out is D0, which was the missing one up here. This is Sparky's grabber out. Then we have, these are all over the place too, 59 and 66. Okay, the Sparky antenna out is 66. And 59. These are both just wherever they had room. How contiguous is this table looking? So up to D. Yeah, that's stuff that's been used by the Innovation Lab. I'm also going to expect that as the master computer. Then D through... Okay, we have a gap here. About 16 might be. Oh, you know what? Let's check the soldering iron. I think that's why the cursor might have two sprites, because the soldering iron is two different colors. Right? When it lights up, it turns red at the end. So I don't know what 16, 17, 18 are. But these are looking very contiguous. Okay, here's another gap, 22 through 24. Another little gap, 40. So many gates. E0. Yeah, I want to hunt for more object IDs. Let's take a quick trip to the actual game. Yes. Let's turn the speed down. Alright, these are looking pretty normal. Let's load a file from later. Oh, did that just reload everything? I have to paste my debug in there again. Oh yeah, the master computer is over here with sprite objects 1 and 2. Which I think I already had documented. Alright, 39. Yeah, 39 through 40. So we just need grabber and antenna. Oh, I'm just noticing this node thing was actually left over from an earlier naming scheme where I thought I was going to label everything that was electrically active in a different way. I don't think I'm going to do that still. I don't have a trailing white space on this machine. I mean, so in terms of interfacing this game with external electronics, I mentioned we could have like a room that represents your Arduino or microbit or whatever. Maybe a way to link in-game chips, like the cool like chip burning concept with making a firmware image. But I like the idea that there are just, like you can go inside of, for example, like an in-game representation of your microcontroller and then wire stuff up in there. Or we could just use this to send MIDI messages and make interesting game noises. Okay, so a 9 is the grabber input. They probably added this one way at the end compared to the other robots. Like, oh, we have enough memory, we can make 4 robot puzzles. I don't know. It's my half-baked theory. Antenna in is B, out is C. What kinds of other objects are there? So this looks like stuff that we've mostly seen, like 12. Yeah, like these are pretty normal. Oh, here's the key. That's FA. Is that one of the game items in those 6 slots? It is. The key is shape 5. Let's turn on cheat codes. Control E. Now collision detection's off. '22 and '23 are the Dalek. Yeah, I don't know what that would be in the lab. '22, let's call that Dalek left. I don't know if this is like a generic enemy slot or something, but some kind of 2-part animated enemy. So also the sentries in Robot Odyssey are not done with the original sprite system they built on. Those are rendered separately. Whoa, what is E1? That's my toolbox. I guess I hadn't used my toolbox, and that was just like where it was left in the level editor. I don't need this key. E9 is chip 3, is that right? Yep, E9. Is the subway token going to be another one of those 6 game slot objects? Where's the subway token? This level might be even more confusing when you're not going through when you're not subject to collision detection. There we go. 4. Huh. That's interesting. So that is not one of the general purpose game objects. I don't know what World 0 object is. I'm gonna... But these are definitely not common objects. Let's just label that subway token. That's object 4. Let's replace this. Or, I mean, this isn't just used in the subway, let's just call it token. Yeah, well, I don't think I'm going to go through and label all the objects in the game, but... oh, 24 is a handle. Oh, that's cool. It's right after the Dalek. That is a vending machine handle. Oops. I mean, I could call the train, but I can also just, like, walk through the walls. The train doesn't seem to be a sprite. Exit ticket. Another game object. Yeah, that loops around. I guess I have to go back up into the actual subway portion, I think. There it is. Exit tickets F7? That seems like a game object. That is a shape. Shape 2. Yeah, alright. Okay, let's try to find the code that simulates electricity so that we can add a hook. So we're looking for something that is specifically looking for the remote control sprite. See, this is not right. I think this was based on some reverse engineering that turned out to be incorrect. I'm going to label that as unknown again. I don't know if this is right either. The toolbox is closed flag. Let's not worry about that right now. Okay. So we're specifically looking for this RO object antenna. So something with an offset of FC, or like, what would the color be? Like, or no, we're not looking at the color, we're looking at the sprite ID. Sprite ID 1. So it'd be 1 FC past the world. Okay, let's find this stuff in the game binary, but see if we can cross-reference it to the lab binary and maybe the tutorial. Oh yeah, the menus are not useful right now. This was when we were working on cutscene stuff several streams ago. Alright, let's go back to the game. Alright. So I don't know how this would be referring to the world data. I had a symbol for the actual world data in RAM, don't I? And we could use the emulation to actually figure out memory addresses for this stuff, but I think I've got this annotated already. Alright, I've got load world file. Buffer, is it DX? Alright, so this is the end of the world, this is the beginning of the world. 10 EC. And like, I don't see cross-references directly to this. Like, I would expect it to be something that happens in each of the... So these are the game main loops. Each world has its own separate main loop. Some of this is annotated, a lot of it isn't. So handle special keys, collision detection, key state. And then there are a couple of sections here that are protected by conditionals. So you can see some of these are sections of the game, like the disk terminal submenu. Are these room numbers it's checking? These look like special purpose flags. Just something sitting here in the data segment, yeah. We could also look for the chip simulation code, which I think I've annotated somewhere around here already, and then just work backwards and find the remote. Video frames. I'm guessing these flags were set somewhere else based on world data. Another hint is looking at the address regions. Like, you can expect that the game is going to be broken into subsystems, and like the circuit simulation and the world rendering and different individual levels would be in specific parts of memory. We can also get an idea of maybe what's common to all these loops and just look at that. But I suspect we're going to see a ton of stuff still. We could also look at, we could do memory tracing, like we could see what memory is actually updating the circuit. Let's try to remember what I've already got annotated from previous excursions into here. Text rendering, blitting, object intersection tests. Oh, here we go. Locate the circuit data by finding a reference to it in the code that draws all the wires. Let's look at this code again, maybe. Yeah, so what is this? Let's just find that address. I mean, we could do this in a number of ways. When I ran this build, it would have given me all the addresses it came up with. So game.exe, we're looking for this pattern that starts 80ref9ff. that's the right one. Yeah, location 6376. So my notes from earlier say this is a function that draws all the wires. Yeah, why is this a negative offset? That's better. These offsets are just not right. But that's better. If I just press O, I'd guess is the right configuration here. And now these are all being treated as indexes into arrays, which I think this is the circuit data. So I think what this is going to be doing is loading the values for the current wire into these global variables, and then calling, I assume these are line drawing routines. Rep Stosby. Certainly could be. This is move and or inc. That's probably the vertical line, and this is the horizontal line. Draw wires, maybe. So this is called from all the main loops. So we should be able to find the function that clears the frame buffer too. Because here's this, so everything that draws on the screen is going to be in between. At the beginning, we expect to see something that clears the frame buffer, or possibly like right at the end. Then all the stuff that builds up the frame, and then finally the blit that copies the back buffer to the front buffer. So the whole frame contents will be before this. And then where's the frame buffer address? Video blit. Yeah, this is the blitter. Okay, so there's a hard-coded address here, which I don't know why this is the same value in all the binaries, but it seems to be. All the binaries seem to, at this address, have a pointer to the actual back buffer at 3AD5. Why is this B800? I'm guessing that this is initialized to the, so this is the hardware front buffer. But I think at some point we would be setting up the back buffer and replacing this with a pointer to the actual back buffer. Like right here. This is the data segment offset of the back buffer. And it's converting it to a paragraph by shifting it by 4. So video blit frame is using that. Who else is referencing this? Here's clear screen. Is this? I don't know if this is the same clear screen we use later. It's pretty basic, right? Clear screen. Alright, well, where is the draw wires function? That's 635F. Around 2300 in linear. So maybe this is another similar drawing function. I don't know if the circuit simulation would be near the drawing code for the wires. Probably not. I feel like if they were writing code to check the state of the remote control, I don't know why they wouldn't just refer to that particular byte of memory directly. You know, I'm curious if we can find this relatively quickly by looking at the chip simulation code. Where's the chip simulation code? Have I labeled any of this in this binary? I don't think so. I've got more of this labeled in like tutorial and lab, so maybe it'd be worth going back to lab. Let's maybe open lab in parallel. This one, that's the tutorial, there's the lab. Alright, do I have any of the world or circuit stuff labeled here? So this is the innovation lab. This only has two main loops, one for the lab proper and one for the tutorial, which one of the tutorial worlds uses the same binary. The buffer, world data pointer, offset. Okay, and I've actually labeled most of the world data here. This is much better. So we've got the world XY, color, room, sprites, sprite ID. Who uses sprite ID? Lots of stuff uses sprite ID. Nice. Anybody using this with static offset? Not so much. There might be just like a get color. Let's look at the main loops first though. So similar, we have a set video mode, some input. Oh, look at that, simulate all chips. I had this one labeled already. Well, this is probably going to be the remote control test then. So what is byte 19345? And can we check to be sure if this is actually the remote control state? We could read this byte directly into the game memory and watch it change if we wanted to. I just have to do a little address translation. This is the lab binary. Okay, I think we put the data segment at OX100 here. So let's go to the lab. Okay, not get game memory. Get game memory is like the kind of cooked memory format. We actually want to just get the virtual machines, well, the like emulated machines memory. Let's get memory. This is just a flat array of 256K. I'm gonna call this mem. And then this would be address plus, this would be 9345, so A345. And does that change if I turn on the remote? It does. That certainly looks like the remote control state. So, but I think this is actually set by looking at the sprites. Let's find where that happens. That's pretty straightforward, actually. This is great. This must be the current key, or like the keyboard buffer. I'm going to call that last key pressed, and I'm going to call this update remote control. So this is looking at sprite ID table, sprite ID, the sprite for object FC, and checking to see whether it's equal to 1A. Toggling it to 1A, or sorry, this is toggling it, we're toggling it to 1A or 3.6, and setting, oh, no, this is toggling it in that remote control state variable, but then writing it to the sprite table, but actually writing it to the sprite table won't change the in-game electricity state. I wonder if it's worth documenting the address of this flag externally. It seems like this function would be pretty easy to pattern match against. And let's make sure this is not part of the circuit. I don't think it is. I think this is just external. How do we set this when the game loads, though? Where is this? Oh, this is part of the circuit. See that circuit data end. Why didn't I see this before? I thought I had a diff tool that would have noticed this. Let's do this. I'm not seeing that change in the circuit. Why not? What is the actual offset here? So remote control state here is 9345. BB6. Oh, really? Maybe my array is too small. N34A. I think I might be missing 5 bytes. You know. Oh, I'm missing a lot more than 5 bytes. Oh. Why is this so little? Only 1556? Okay, where am I getting circuit data end? You know, I might have gotten the size from a different binary now that I think of it. I was doing a bunch of this reverse engineering on the tutorial for some reason, And I think the tutorial data structures, some of them are smaller. Because here, I actually have a definitive beginning and end because we're loading this stuff from a file. But where am I getting the address? Yeah, so we're looking at that wire-related reference to find the beginning of the circuit. And then the end of the circuit is just based on the size in this header file's RO circuit data structure. I'm going to delete this because I don't really care. This is all a work in progress. Those comments, I think, are more misleading than anything. Okay, 1940. 794. Okay, what else in here can I turn into arrays? Okay, start is 8BB6. So I'm assuming we've got some 256 entry arrays here. So this unknown, does anybody use that here? Yeah, I think that first array is like circuit states. I'm also thinking these probably are not wires so much as they're like circuit objects. I'm tempted to call that states, but let's just get the sizes right and then worry about the names. So this is that one that's unknown. This is circuit X1. This is circuit X2. X3, Y1, Y2. This should be 256 also. Okay, BB6, CB6, DB6, FB6. Ooh, now we got some other stuff. Oh wait, maybe I'm getting those two confused. I think these are flip-flop states, right? I think these are the two halves of a flip-flop. $55, huh? Really? What's at 1B6? I don't know. Are these arrays? Those are definitely arrays. But they might not be 256. These are probably gate-shaped arrays. Yeah, let's just make one big array, unless the structure is obvious. Let's make one big array for the rest of this. Although, actually, I don't know. I think we've got some good start addresses. Okay, let's do this. So, 8BB6. OX500, I don't think that's 100 long. And 90ED. Let's take, let's measure the distance between these. So, in fact, let's just turn these into arrays. Like, I'm pretty sure I want an address here. I'm pretty sure it's gonna be flip-flops. Good 64 entry arrays here. So wait, what was this again? This was 55. 75. I'm just going to get the overall structure here, and then I'll start filling in more details. Oh, Took. 204. Okay, that's the 55, that's the 75. Then, oh. What? I hate stuck keys. Okay, how many 64s do we have? Is that 5 64s? And then this big one. End is at 934A, and then this weird length table is at 927A. DO. I think this might be the right length though. 204. And that's 6 individual bytes. I think this isn't actually part of the file. I'm just labeling these arbitrarily because I want to get the size on the structure right. For E. So is 754 the right size? How big were these files on disk anyway? Let's just unpack this. Oh, I already had these unpacked. 1556 for the tutorial. Is that, yeah, that must have been the problem. Using the size from the tutorial when really there's a lot more stuff in the actual game. So yeah, sewer.circuit is in the same format the actual game uses, and that's 1940. And the lab, is there's no circuit file for the lab, is there? It's frustrating if these three binaries all have mutually incompatible circuit files. Not that big of a deal, it just does mean I have to really focus on which one I want to figure out first and keep them separate. So 934A. BB6. Let's not do that in hex, actually. Yeah, you know, I think the lab and the game have compatible formats. At least just going by size. So maybe don't panic. Maybe let's just make sure this is right. Where's my discrepancy? B6. Okay, so that was this first weirdly shaped array. The second weirdly shaped array, 90ED. And 238. missing one more 64. I am. 6C2. How do I get all the way to 6C2? Let's start giving these better names. Because this was an array of 55. Five 64 arrays, and then the 2 of 4. This should be at 6C2 and 9238, 682. What? I think there's another array in there that I wasn't seeing. 9278 minus 9238. That is only 64 though, isn't it? Oh, I'm just making stupid mistakes. Here I was adding 2 instead of adding 4. That is 6C2. Okay, and then this one, 9344. 78E. Yeah. Okay, 794. Yes, 794 is correct. So if I recompile this, we should get the whole RO circuit data. Was that? Oh, that didn't actually do anything. My makefile needs to be smarter about dependencies. Right now it doesn't really know about all the C dependencies. And yes, I know about dependency auto-generation. I'm just too lazy to set it up for this makefile. I'll do that later. This cat hair all over my desk. All right. And this should be remote control state. OX790. Okay, well, the other thing I wanted to do here was actually, besides mapping out the data a bit more, to figure out where would be a good place to add in like a hook that would get called in JavaScript when the remote control should do its thing. Is it better to do this before or after the game tick? Between game ticks, maybe? Before. Before and after. Before and after is more complete. I'm a little worried about just, unnecessary trips back and forth between the WebAssembly land and JavaScript land, but it's probably not a big deal. Alright, we're not in the circuit. 1940 bytes. And let's try diffing it using this thing. Okay, a lot of those changes are actually because the robots are next door doing stuff. Let's turn off the remote. Now 78F has gone from 1 to 0. Oh, 78F, so it's actually this one. Is that right? It's the second of those bytes. Because I thought it was the third. Oh no, it is the second. And there are 4 bytes after that. Okay. I mean, we could probably try to figure out what the rest of this stuff is. Let's see if some of this, well, let's see if it at least is compatible with lab. What did I do? Oh gosh. That was an unnecessarily huge diff. Okay, that's a better diff. So we've got some world differences due to what? Those are the crystals flashing. And those are just the positions of my sprites associated with the cursor. 78F is still a remote. So wire 0 is definitely the hot cursor. It kind of looks like the hot cursor is actually implemented as like a 1 pixel wire, which is interesting. So at 500 and 501, I think we have the states for that first flip-flop. Two and 3 for the second flip-flop. 4 and 5. I don't know if I feel like mapping out the whole circuit state right now. Let's stay on topic slightly and think about how to add that hook function. It does seem like lab and game are probably the same format. Okay, so this is some input related stuff. And then circuit simulation. I mean, we already, of course, get a JavaScript callback when a frame is rendered, which might be close enough for this. This looks like a list of object IDs. Like, it's definitely going to have lists of, like, propagate this signal from here to there, stuff like that. We might have just found something like that. Oh, is this the hot cursor? We're comparing object positions. This could be an intersection test, like for the hot cursor. So each main loop is going to have its own little smattering of calls here. Some of these are even different. Like, it looks like they might just have added like level-specific electrical stuff at the end here. Or maybe they're just in a different order. Are there actually going to be differences in how the electrical simulation works from level to level just based on the order they call these in? Like, this one seems to be unique for that level. Which might... is this the tutorial? Definitely looking at the sprite data and the room data. I mean, I know where the circuit data is. Can I just look specifically for this move that checks the remote control state? This is 9345. I could do that. I mean, it would also end up matching this code right here. Okay, well, it's getting kind of late. I don't want to make this like a super late stream, but I think I might punt on this problem because it seems like there are a few different ways to add callbacks to the main loop, and I'm not really sure which way is actually better. Let's try doing something kind of temporary using the rendering callback. But let's commit this change, because this is definitely an improvement. That's a lot of improvement. All that. let's say, would it be more fun to try to get data into or out of the robot circuit? The Robotropolis circuit, the Robot Odyssey lab, or something like that. I mean, we could make an electrical output that plays some sound. That might be fun. We could hook some inputs up to the mouse. Like, what if we wanted to encode the mouse's x-coordinate in binary and then put that on the prototype chip? It's kind of arbitrary, but it might make a fun test. Let's add that to my little note file here, which is kind of a messy place to do stuff, but I like it. Okay. I need to tap into the input then. How does that work? Let's override set mouse tracking also. Let's also not bother reassigning that to RO engine. So we're just going to override these two functions, which would normally be implemented. Well, this first one is like inline. Well, actually, no, this first one's called by inline JavaScript, but then it's implemented in the sort of output subsystem of the JavaScript for this page. And then set mouse tracking is implemented in C++ and called by the JavaScript. We're going to override both of them. Just have global variables for mouse X and mouse Y. So pretty basic, just storing a copy of the mouse coordinates and then passing them on. And then this gets called to render a frame. We're just going to pass that on to the original implementation, but then also do some stuff to the game memory, because it's a good time. Let's also have a reference to the world. Okay, I need a list of pins that we're going to set and colors that we're going to set them to. So also, I think the game, so probably in some code very similar to where we just were in the binary, but I haven't actually found this yet, it's going to have some code that propagates the pins between the inside and outside of the chip. So if these are outputs, for example, and we're writing to these, I think those writes will only last one game tick, and then they'll be overwritten by the next data from the inside of the chip. So I think we actually want to write these directly to the inside pins. So starting at 3.9, let's use the game's native order instead of my counterclockwise orders to make things simpler. Actually, that's a terrible idea. That sounds really confusing. Let's use counterclockwise order. So I'm going to use the pins in the right order. Okay, 8 pins. And the colors, I want these to be 0 and 1. So yeah, cold is 7, hot is 5. Okay, and then I'm just going to do for var bit, so 8 bits, and then world, I'm just going to spell this out world, because, well, no, W is fine. W is good enough. Colors, that would be OX 400, 200. So color table is OX 200 plus the specific pin that we're looking at. So indexing into the pins array using bit and then adding that to OX 200. That'll be the color. And we're setting that to the appropriate color. This will index with a 0 or 1, basically the bit that we're looking for. And then the byte that we're going to send, I'm just going to make that the mouse X, and just AND it with FF just to make sure, but it should already be, like, I don't think we need to do that. Let's just send the mouse X. So if we paste in this code in the console, it'll override the render frame and set mouse tracking, so that set mouse tracking will keep track of the mouse position. And then immediately after every frame renders, we go modify the game memory to put a new binary number on the input on the inside side of the prototype chip. So let's get a new window here. And I want to go ahead and set the direction, because I don't know if any of this will work if the pin directions aren't set. Let's make some room. I'm just going to bump up the speed to 2x also, which is not completely disorientingly terribly fast, but is faster enough that you can move around a little more easily. I could even try doing some logic with these, right? Let's try something like that. Alright, let's paste in the code. Let's first just try this first section. There's mouse X. Oh, it's a floating point. Let's at least cast an integer here by ORing with 0. I kind of do just want to AND this with OXFF for completeness. That'll make sure it's a byte. Oh, we got some states there. I think it's working. Oh, that was, when I moved the mouse all the way off the left edge, there's actually a feature that sets it to -1. So that's why we're seeing all ones. Because I'm not clamping, and it does actually go negative. But if I just move it here, you can watch it count. We won't actually get all the way up to 255 here. But yeah, that's input into the circuit. And if I wanted output, like, I don't know, actually it would be kind of interesting just to like print out the value from the outside of the chip. Let's call those inside pins. And let's get the outside pins too. So this is 1 through 8. I don't know if I care about this colors lookup table because I'm going to hard code something else related to that. Let's just use the ternary operator. And then outside byte. Does JavaScript have or equal? Yeah. So same thing, world OX200 plus outside pins bit. I'm just going to say equals 5. Oh, you know, I could just put this on the screen. Oh, let's create the context and the globals too. I don't even really need this to be part of the canvas, right? Let's just make it big so I can actually read it. Let's see if that works. Oh, it's off the edge of the screen. Yeah, that's bad in many ways. guys. Cool, so that circuit's running over there. Let's see if we can override one of these. Okay, so I just made it no longer an output, but I'm still totally setting it, and it seems like the signal's propagating from input to output. What if I make it an input? Ooh, if I make it an input now, I can control it from here. So now the top nibble is going from the mouse to the chip. This other nibble should be going from the hot cursor back in. So 8.8, 8.4, or 4.4, whatever. Now it's 8.4. So the top nibble is based on the horizontal position of the cursor, and the bottom nibble is based on what I'm feeding into the chip here. So, bidirectional communication. You know, a lot more to be done to make it actually useful or whatever, but I can imagine using this to control actual electronics or MIDI instruments or make noises or whatever. Anyway, I think I should wrap this up. That's been interesting. We'll do some more of this later. Thanks for stopping by. Yeah, if you want to play with that, a lot of this, as you can see, as you might be able to tell, you can do just from inside the JavaScript console. All right, well, that's it for today. Thanks so much for stopping by, and I'll see everyone else later. Yeah, special thanks to everyone who supports the channel. I really appreciate the hardware people send in. I know this one's been waiting. We'll get to this shortly. Maybe even tomorrow, depending on streaming schedule stuff. Yeah, yeah. Hopefully the collection of stuff we do here is interesting. But as usual, I appreciate feedback, and hopefully we can do some education and some entertainment and make some things and take some things apart and just have it be a good mix of stuff. So, thanks everyone. I'll see you next time. Happy hacking.